Now, today we are going to finish up 5-5, solving polynomial equations. We started this yesterday with the factoring. And we talked about sum of cubes and difference of cubes and how you just plug those numbers into this formula here. And then we talked about factoring by grouping. And then y'all started working on your assignment, right? Okay. All right, so now we're on page 3, and example 3 says combine cubes and squares. So we want to factor. That's our directions. Example 3a. X to the 6th minus y to the 6th. Now, do we have a GCF? No. Okay, but we do have a difference of squares. Any even exponent is going to be a perfect square. Okay, so we can apply the difference of squares rule, which is you take the square root of each term, put a plus and a minus in between them. Okay, so this could be rewritten as x cubed squared minus x cubed squared. Okay, that's x to the 6th minus x to the 6th. So what would be the square root of x to the 6th? X cubed. So, and then what would be the cube root? Oh, that should be a y right there. What should be, or what is the cube root? What is the square root of y to the 6th? Y cubed. So we have x cubed plus y cubed, x cubed minus y cubed. But we're not finished. There's more. All right, so if we look at this, how many terms do we have? 2. And I see automatically that I have perfect cubes. So this is a sum of cubes. So we're going to take this and we're going to apply this rule right here where we have the two factors, a binomial factor and a trinomial factor. So we'll have a plus here and then a minus plus. Okay? So what is the cube root of x cubed? X. What's the cube root of y cubed? Okay, now we're going to use these. The first one we're going to square. Okay, minus, then multiply them together. XY, and then square the last one. Y squared. Now look at this one. What is that one? A difference of cubes. Okay, so we're going to have the same idea. Except we're going to have a negative here and then 2 pluses here. And everything else will be the same. It'll be x minus y, x squared plus xy plus y squared. And you're done. So the reason that it's called combining cubes and squares, actually we combined them all. We did difference of squares, then we did sum of cubes and difference of cubes all in one problem. All right. Now look at this one. We're going to factor this one also. A to the 6th plus b to the 6th. Okay. Now, does this one look similar to the one above? Okay, the only difference is it's what? It's a sum. Okay. Now, up here, we applied the difference of squares. Do we have a sum of squares? No, there is no sum of squares rule because if you have a sum of squares, more likely it's unfactorable. Okay? So, I don't have a difference of squares, but these are also perfect cubes also. So I could rewrite this as a squared cubed plus b squared cubed. So what would your cube root of a to the 6 be? A squared. What would the cube root of b to the 6 be? B squared. Okay? So we're going to use our sum of cubes. So the cube root of a to the 6 we said was a squared, just right here. And then the cube root of b to the 6 is b squared. Now we're going to square the first one. What is a squared squared? A to the 4th. Then a squared times b squared would just be a squared times b squared.
So this is the sum of two squares?
Yes. And then what would b squared squared be? And that's all you can do with that one. Okay, moving on. Now we're going to solve some equations. We're going to solve by factoring. And it's going to be the same way that we've done quadratics. We're going to set it equal to 0 and then factor. Okay? So, since we're factoring, we want to set it equal to 0. So, write that down. Make sure you don't forget that. So, example 4a. X cubed equals 8x squared. So, what's the first thing I want to do? All right, how am I going to set it equal to 0, Rayleigh? Move this over here, right? So subtract 8x squared from both sides. So x cubed minus 8x squared equals 0. All right, who can tell me what I want to do now? I'm ready to factor. Raise your hand if you know what to do. Everybody ought to raise their hand. You should know what to do when you're going to factor. Jackie? GCF. Do we have a GCF?
Yes.
Yes, x squared. So factor out an x squared. What do we have left? Now, this is a linear factor. In other words, the exponent is 1. And you can't do anything with this. So we're done factoring. So if we were just factoring, we would stop and we would box that and that would be our answer. But we're solving, which means we've got to go one step further. We got to set each one of them equal to 0 and solve. So x squared equals 0. X minus 8 equals 0. So take the square root. And what is the square root of 0? 0. Okay? If we have x minus 8 equals 0, what is x going to be? 8. So our solutions are 0 and 8. That's where it's going to cross the x-axis. Now, since it's a cubic function, a third degree, it could cross the x-axis up to 3 times. But this one's not. It's just going to cross twice. Okay, now look at this one. And again, we're solving. X cubed plus 10x squared equals negative 25x. What are we going to do first, Aliana? Set it equal to 0, and how do we do that, Aliana? Add the 25x to both sides, so we have x cubed plus 10x squared plus 25x equals 0. Now what, Mercedes? Okay, and what's my first step in factoring? Yes, look for GCF. Do we have one, Mercedes? Okay, X. So we factor out an X. And what do we have left? Let's see, Yannette.
X squared plus 10x plus 25.
Good. Now, I have 3 terms left right here, and it's a quadratic. So that tells me I'm probably going to use product and sum, since I have a coefficient of 1. So I have 2 factors that begin with X. Want 2 numbers that multiply to give me 25, or have a product of 25 and combine to give me 10. And now that's as far as I can go. So I've got 3 factors here, but 2 of them are the same. So you don't have to solve for it twice, okay? It's only going to cross the x-axis in that one spot. It's what's called a double root, okay? So set the x equal to 0, and there's your answer. X is 0. All right, x plus 5 equals 0. What would x be? -5. So 0, -5 are my solutions. Okay. And example 5, we're going to talk about quadratic form. Okay, and the directions here are going to be to factor. We're not solving, just factoring. Example 5a, x to the 4th plus 5x squared minus 6. Okay, so I want to factor. I'm looking for GCF. I don't see one, do you? I'm stuck. I don't know what to do. There's no difference of anything, no sum of anything. But it looks vaguely familiar. There's something about it that seems familiar. How many terms is it? 3. And I have a constant here. So what does it make you think of? What kind of? A trinomial, but usually what's our exponent right here?
It's a quadratic formula.
Right. Usually it's a quadratic. Okay, where we have a 2 here, 1 here, and then our constant. Well, since this exponent is even, this is what's called quadratic form. You can use the same strategy because x to the 4th is the same thing as x squared squared. Okay, so where we used to have an x here and an x here, now we have x squared squared and 5x squared. So in other words, if the exponent, the first exponent is even, the highest exponent, and the other exponent is half of that, then it's you can use quadratic form, which means you can factor it just like you would a quadratic. This is a trinomial, has a coefficient of 1, so we use our product and sum. But instead of x at the front of each factor, what would we have? X squared. Then we want 2 numbers that multiply to give us -6 and combine to give 5. Three and 2? Well, if I have a +3 and a +2, that'll make 5, but it gives me a +6. If either one of them is negative, I get the -6, but I don't get the 5. All right, 6 and 1. And since the 5 is positive, we want the larger one to be positive. But now, I don't have linear factors here. They're both quadratic, so I better look at them closely. Now, since they're quadratic and they're only 2 terms, the only thing I'm looking for is difference of squares. So is x plus 6 a difference of squares? No, it's not even a difference, much less difference of squares. What about x squared minus 1? Is it a difference of squares? Is it a perfect square minus a perfect square? Yes. So I can factor this. X squared plus 6 cannot be factored anymore. Shh. But this one can be factored into x plus 1, x minus 1. And that's it with factoring. Now, if we were going to solve it, we would set all three of those equal to 0, which would end up with the I term over here. So the ones we solve here in a minute the answers will be more simplified. All right. I'm going to factor this one. X to the 8th minus 18x to the 4th plus 81. No GCF. So I want to look for quadratic form. Is it quadratic form? Yes. Because that's even. This is half of that. So this would be x to the 4th squared. Okay. So 2 sets of parentheses, but what's going to go at the front here? X to the 4th. Okay. The square root of x to the 8th is x to the 4th. Now, two numbers that multiply to give 81 and combine to give negative 18. And if you foil this back together, you get this right here. You can try it and see. All right. Am I done?
No.
Who says no? Cyrus, what do you think we need to do? Or are you just taking a wild guess? Well, yeah, we can keep factoring it, but why? All right. Yeah, you can. You're right. Gabe, the difference of squares. Because if you have an even exponent, it's a perfect square. Because this would be x squared squared. And 9 is a perfect square. So this is going to factor into x squared plus 3, x squared minus 3. And that happens again. Now, these are quadratic, so you better look at them carefully. What's the only option we have, possibly, for factoring if it's a quadratic with two terms? A difference of squares. Do we have a difference of squares in any of these? No. So we're finished with the factoring. You can write it like this if you want. So either one of these will work. All right, one more. And this one, we're not going to just factor. We're going to go a step further and actually solve it. Okay, this one's already set equal to 0, so that's taken care of. GCF? No. So, who thinks they know what we might need to try here? What's it called? What's this thing called when it looks kind of familiar but the exponents? Quadratic form. So this is even, that's half, so we can use our quadratic form. So what goes at the front? X squared, x squared. What multiplies to get 4 and combines to get negative 5? Negative 1 and negative 4. Am I done? No. Can I keep factoring? Both of these are difference of squares. So this would factor into x plus 1, x minus 1. Whoops. Where did I get x minus 5 at? And this one would factor into x plus 2, x minus 2. So set each one of those equal to 0. So I'm going to skip a step here. I'm just going to go ahead and put it in my little thing here. So if x plus 1 equals 0, what's x? -1. If x minus 1 equals 0, what's x? 1. If x plus 2 equals 0, what's x? If x minus 2 equals 0, what's x? So that one has 4 solutions. But it's a 4th degree function, so it could have up to 4. Now, graph-wise, if I was looking at the graph, what do these numbers mean as far as looking at a graph? Who can tell me? Raise your hand. I'm going to start calling on y'all more. Think about what it means. Neely, I know you're ready. Did somebody else have their hand up besides Gabe and Neely? Because I hadn't already asked y'all today. Gabby? What'd she say?
It's where they cross the x-axis.
It's where they cross the x-axis. It's the x-intercepts. So get your little calculator out that you have right there. Put in your original function when it was set equal to 0. What is it? X to the 4th minus 5x squared plus 4. So put that in for your... There's 4 up here on the charger that are ready to go. Okay, does anybody have it in yet? Putting in your original function, x to the 4th minus 5x squared plus 4. Plus 4?
It's a straight line.
No, it shouldn't be a straight line. You probably either left something out or put something in that shouldn't be there. Shh. Okay, do y'all have it? Where am I expecting it to cross the x-axis?
That's not a straight line.
Where am I expecting it to cross the x-axis? At those 4 points, because Gabby just told us that was going to be where it crossed the x-axis. And there you go. Where does it cross the x-axis? -2, -1, 1, 2. Okay, so it makes a W shape. Okay, so you can see the relationship between the algebra and the actual graph. Okay. Now we're going to get ready to do our assignment. 5-5.